Welcome to This Explainer. Today we're diving into the solar sheep, cellular theft, and biological innovation. We're actually going to investigate what might just be the absolute greatest heist in the natural world. And no, we aren't talking about stolen diamonds or cracking bank vaults today. We're talking about a microscopic biological heist that literally bridges the gap between the plant kingdom and the animal kingdom. We're going to unpack exactly how one tiny creature manages to steal the very power of the sun. It's a masterclass in biological engineering, and we'll break down how it works, why it happens, and what it all means for the future of science. So get ready, because this is going to completely change how you view the boundaries of nature.
So I want you to think about this. What if an animal could harvest the sun? It feels like a paradox, doesn't it? I mean, it basically challenges everything we're taught in elementary school biology. We learn that animals have to consume food, right? They forage, they hunt, they eat constantly just to generate enough energy to survive. Plants, on the other hand, well, they have the incredible luxury of just sitting in the sunlight and making their own food. That's the fundamental divide in the natural world. But imagine a rule breaker. Imagine an animal that just decides it doesn't want to play by those consumer rules anymore. What if an animal could just bask in the light and generate its own internal energy? It sounds like pure science fiction, but as you'll see, it's entirely real.
Meet the leaf sheep sea slug. Now, don't let that cute name fool you. While it's roughly the size of a grain of rice, we're talking usually just 5 millimeters long, and yeah, it basically looks like a tiny cartoon sheep grazing on algae. It is an absolute powerhouse of biological innovation. The leaf sheep has developed a survival strategy that completely upends our traditional understanding of biology. Because instead of just existing as your standard consumer in the marine food web, this little sea slug has found a way to become something else entirely. It acts as a living, breathing laboratory, perfectly illustrating the incredible adaptability of life. By looking at this microscopic organism, we're essentially looking at a biological pioneer that has completely hacked the system of energy generation. The secret behind all this is a process called kleptoplasty, which is the biological process of consuming green algae and retaining its chloroplasts. As the name suggests, with klepto literally meaning to steal, this is cellular theft at its absolute finest. You see, the leaf sheep isn't just eating its greens to digest them for basic calories. Nope, it is actively stripping the algae of its most valuable internal components, the chloroplasts. Those are the tiny structures inside plant cells that are responsible for catching sunlight. The sea slug plucks them out and keeps them totally intact. It's kind of like if you ate a salad, and instead of digesting it, you somehow managed to extract these solar-absorbing cells and line your own skin with them. It is a phenomenal evolutionary trick. So, how does this microscopic heist actually go down? Well, step 1, consume green algae. It starts just like a normal meal, but then, rather than destroying the food in its digestive tract, we move to step 2, retain chloroplasts. This is where the biological magic actually happens. The slug's body identifies these structures and safely stores them. And finally, step 3, hijack photosynthesis machinery. The leaf slug doesn't just store these stolen chloroplasts like some useless cargo in a trunk. It actively plugs them right into its own biological network. It essentially hotwires the stolen plant parts so they keep functioning inside an animal host. It's an incredibly sophisticated biological integration process, all happening on a microscopic level.
And the direct outcome of this hijacking process? Internal solar energy generation. Because the slug has successfully integrated those stolen chloroplasts, they continue to do exactly what they did when they were inside the algae. They photosynthesize. They take in sunlight and they produce energy, but now they're producing that energy directly inside the sea slug's body. The slug can actually sustain itself for months at a time, simply by generating solar energy internally. It has effectively turned itself into a living, moving solar panel. No way, right? It doesn't need to constantly graze or hunt. It just needs to find a nice sunny spot in the water and let its stolen cellular machinery do the work.
Now, let's look at the animal kingdom's typical energy consumption versus the plant kingdom's solar photosynthesis, because this is why this phenomenon is so staggering. For millions of years, nature has had this rigid divide. Animals must constantly ingest and break down organic matter, while plants enjoy the elegant simplicity of creating energy right from the light. These two processes have always been separated into two distinct, rigid kingdoms. But the leaf sheep sea slug, it completely shatters this binary. By utilizing kleptoplasty, it bridges this massive gap. It exists right in the space between the two, proving that nature's boundaries are far more fluid and flexible than we ever realized. We are literally looking at an animal functioning with the energy independence of a plant.
All right, moving beyond survival, let's look at the big picture. why does all of this matter to us? We have to look past the sheer novelty of this incredible creature. This isn't just some quirky nature fact you memorize for trivia night. It is a profound scientific model. The leaf-sheep sea slug serves as a vital, living subject for researchers all around the globe. By understanding exactly how this miniature organism manages to tolerate, integrate, and utilize completely foreign cellular machinery without its own immune system just attacking it, scientists are unlocking fundamental secrets of biology. This tiny slug is holding the keys to technological and medical advancements that could legitimately shape humanity's future.
Specifically, the leaf sheep helps us study three massive scientific frontiers. First, it explores synthetic biology. If nature can engineer an animal to run on plant parts, it inspires scientists to figure out how we might engineer entirely new biological systems. Second, it studies cellular integration. How exactly do cells from two entirely different kingdoms communicate and function together without rejecting each other? Figuring out that integration is a massive hurdle in science right now. And third, it inspires medical innovations. Think about it. If we can learn how a slug successfully adopts foreign cellular machinery, we might one day apply those exact same principles to human medicine. We could maybe integrate specialized cells that fight disease, repair tissue, or even generate energy for failing organs. So I'll leave you with this. If a sea slug can integrate plant cells, what could future medicine achieve? It's an incredible thought, isn't it? We started out today by looking at a tiny marine organism pulling off a cellular heist to steal the sun. And we end up looking at the absolutely boundless potential for human medical advancement. The leaf sheep proves that the biological integration of vastly different cellular machinery isn't just a theory, it's entirely possible. The blueprint already exists out there in nature. It's now just up to us to decode it. Thank you so much for joining me for this explainer. I really hope this deep dive into kleptoplasty and biological innovation has sparked your curiosity and left you eager to learn more about the boundary-breaking secrets hiding right in front of us in the natural world.